But thank you, everyone.
Perfect. Thank you very much. Cheers. And thank you once again to our amazing audience for all the great questions you're asking here in YouTube. As I said as well, too, you can tag speakers directly on Slack. We've got our next speaker with us, who is an awesome human being. We've got Jeff Carpenter from DataStax, who's going to be telling us about data services for the masses. Jeff, what's up?
Awesome. All right. How's my video and audio looking?
Fantastic.
Sweet. I'm just going to share my slides out here. And this is all going to work the first time.
Yes.
Oh, yes. Good. Oh, new screen set up this morning. Thanks much for your patience. Yeah, it's super early here. I am super jazzed. This is the earliest in the day I've ever given a presentation. I'm not even sure I want to tell you what time it is here in Arizona, but
what time is it?
It's 3:30 a.m.
Wow.
Yeah.
Okay.
So I'm gonna bring you my best energy, my best 3:30 a.m. energy right now.
Do it, Jeff.
Okay. So I have a question for you to start out with. We're taking a different tack in this presentation. Maybe I know that you've heard from some people that are kind of working on the back end, behind the scenes on some stuff. Just had a great use case presentation from Flipkart. I'm going to take kind of that right there in the middle. We're talking APIs right now. And what the question that I want to ask you is, what is the language of data on Kubernetes? So we want to take a step back and think about application developers, what they need to get their job done. Now, your default answer, maybe it's SQL, and that's a perfectly fine answer. But maybe there's more. So we have kind of this classic showdown that we've seen between people in different roles. So historically, we might have had a dev team that was concerned with getting their app up and running. And then coming kind of with their hands out to a DBA team that kind of owned the database and the creation and optimization of the schema. And there's kind of this the delicate negotiation, shall we say, over who's driving that relationship. And then we started doing things with more integrated teams and DevOps, where we had dev teams owning their own databases. And so that's a positive development as well. But historically, this has been an area of this intersection between application and then, oh yeah, I need to put my data somewhere. That's historically been a friction point in our architectures. And I've seen this personally. So I've been in the industry for a while as a Java developer. I was pretty awesome with Java in the early 2000s back in the day, but I spent a long time working as an architect and an enterprise architect as well. So I've seen these fights sometimes and these interactions from multiple perspectives. So I just want to give a little bit of perspective of things that I've seen over the years. I'm not going all the way back in the Wayback Machine. Don't worry. We're not going before Y2K, but just back a couple of years to see how we've seen this motion toward the cloud and toward microservices working. So I gave this presentation about 5 years ago when I was working at Choice Hotels. I was working on the architecture for a new cloud-based reservation system that we were building in AWS, and we were running it on top of Cassandra. And there was a great SOA practice in place with a lot of discipline, service-oriented architecture. This is before we all started talking about microservices as the next generation of that. And we were building microservices in an on-premises data center and then adopting new paradigms for the clouds. And so we were focused on multiple levels of service due to a lot of the patterns that we had in place in that SOA practice. So you would see a lot of these things called entity services. And these were basically data services, or you might call them CRUD services: create, read, update, delete. Some people like to call them getty putty services, which that's a new one that I like. And then we would have clients that would hit those services, and these services would be responsible for that data interaction. And then they might actually use some messaging to create a pretty advanced at the time, right? Event streams, ActiveMQ. Anybody remember that? RabbitMQ, right? And we would use this to create a stream of the data changes that were going on. But then really the business logic, a lot of the real deal work of the application would be done in these composing services. We might have a few additional message-driven services that were driven to do some downstream alerting or move data perhaps into a data lake. So there were a lot of good patterns that we had. but the responsibility for data ownership was this entity service. Now, what we would do with these composing services is the designs like I'm going to show you here, where we had a separate Cassandra key space for each of the main data types, like hotels, rates, inventory, reservations. And then we would have the entity services that owned those data types in those different key spaces, and these composing services to manage different business processes. So those would be things that spanned multiple of the entity types. And if you want to shop for hotels, you need to compose a lot of information to put a page up on your website, like what hotel am I looking at? What are its rooms? What's available? What do each of those cost? I want to make a reservation. That became another service that was the booking service, and so on. It turned out that we spent a large amount of time creating and maintaining these entity services. So I'm moving a little bit forward in time here. Definitely, we're still talking about 5- and 6-year-old architectures here, but that are still running in production, of course. And so let's look inside the architecture of a reservation service, for example. This is just one of those entity services. So as you can see, there's a lot of complexity inside here, even though all it's really responsible for is just putting data in the database and getting it back out. So it's a Spring Boot application in a sense, running a web server inside it. It's got a REST endpoint it's exposing. It has some entity objects, or DAOs, as we started to call them, data access objects. Those were created as a helpful abstraction so that we could swap in another database if we decided to move away from Cassandra. And then on top, or underneath those DAO classes, there was the DataStax Java driver, which was managing all of our interactions with the underlying Cassandra database. Come to find out, you'll be very surprised to hear that we were writing the same services over and over again, a lot of the very same code, just managing different data types. And it looked a lot like this. On the left side of this picture, you had to install the driver. You had to initialize your connection to the database and make sure that that was sort of properly sized with the right number of connections. You probably tried to optimize things by creating prepared statements that you could reuse again and again with just the structure of the statement and plug in the variables, and there you go. So then you would execute statements when you got application requests, and then you parse and use the results and send them back over whatever API, get a result set in CQL, convert that into JSON or something, put it on the payload, send it back out. On the right side, there was a lot of work also involved that the DBAs became involved in, where data modeling, what data do we need, creating the schema. And if you know Cassandra data modeling, you might be actually designing more than one table per data type. And then there might be some query optimization that would take place as well. So again, a lot of work that was going on just to be able to get data in and out of services. So over the past couple of years, this is a problem that I'm at DataStax now. I have been for the past 4 years since my time at Choice Hotels. And I have seen this problem again and again. I've seen multiple teams that are developing these basically entity services and creating a lot of effort. What we've started doing within the past year is to create something called Stargate, which is an API layer that basically does this for you. So the basic premise of using a data service or a data API, or some people might call it a data gateway, on top of this is you're basically just executing statements against an API. And it could be an API of various different styles, which I'll show you in a second. And you parse and use the results. Then you're not worried about the connection to the database. Where is it? What driver am I using? Have I properly configured the driver? And so on. All right, it turns out that this is definitely not a new idea, even in the Cassandra community. What we started seeing even a few years ago being shared by different companies in the Cassandra community was the fact that they were building these API layers themselves and trying to do it in a generic form. So this is a couple of shots from a talk that Mikhail gave a few years ago. This is about 2 years ago at the DataStax Accelerate conference. And if you see the little diagram here down to the lower left, they've got a Cassandra cluster on the right, of that diagram, and then a Cassandra gateway that they've put in front of that. And you notice that it talks a Thrift API. So they've put an API layer in between their Python and C++ clients. It talks Thrift when their gateway actually on the back end translates that into CQL. Okay, so this is really essentially an entity services or a data services layer. Now, the reason they chose Thrift is kind of interesting because they actually had some legacy code that they had code around that was old enough that it was talking to Cassandra's original Thrift-based API. So this was actually a backward compatibility API layer, which is not everyone has one of those, but that was the situation that they were in for that use case. So let's talk about Stargate. I mentioned that we've talked with a number of companies that have been building their own internal API layers. So this was definitely a pattern that had a lot of traction. And we started a new open source project last year to try to bring these communities together of people. Part of the issue was, of course, everyone is building kind of the API layer for their bespoke architecture, right? So like we saw Instagram, that they were coded in Thrift and they needed to translate the CQL. Everyone's got maybe a slightly different set of what goes in on one side to what goes out on the back end. So for that reason, we started fresh with a new project that we're inviting people in to collaborate on. So what are we trying to do? What are the design goals of a data services layer like Stargate? We're going to try to provide the simple APIs that we can, and then hide the details behind hide the gory details behind here, right? Everyone's like, yeah, right, Jeff. Okay. But the app developers are going to love us when we do this, right? So we want to give them the architectural qualities of scalability. So not having to worry about how big the database is or how many nodes are behind the scenes, the elastic so that it can scale up and down, providing high reliability and uptime. So to summarize, maximum flexibility with minimum trade-offs. These are always our noble architectural goals. The way that this works in Stargate is that it has the pluggable architecture. So on the back end, we're currently able to plug in any CQL compliant database. So that includes Cassandra versions like 3.11 and the 4.0 release, which is about to go general availability. We have a release candidate out there, so that's something pretty exciting for that community. It works with other versions, DataStax Enterprise. We have Astra database as a service that it works with those as well. And then on the front end, this is the really exciting part, is the development of these different API extensions to support different paradigms. So currently supported is REST APIs, GraphQL, and a document style API, which is a kind of a flavor of our REST API. And I'll show you in a second. And it also supports native CQL. And then we're working on some other connectors like Kafka, so we could do maybe some streaming type of interfaces as well. And you can extend it with different authentication providers. No, we didn't leave security for last, like everyone always does, right? So this is a very pluggable framework that we hope will be highly extensible as well. And the careful listener will note that I have not yet said the word Kubernetes, and this is where we make that turn. So when are we going to get to talking about Kubernetes? Well, how about we do that now? So I don't want to steal too much thunder. You are going to hear some talks a little bit later that are going to unpack this idea of Cassandra as a deployment model for Cassandra and a whole Cassandra ecosystem on top of Kubernetes. So I'll preview that very slightly here, and then say that we are within Cassandra have the ability to deploy Stargate as a data gateway on top of Cassandra. And why would you do that? The basic idea here is that we want to be able to provide a full-featured cloud-native data layer that's drop-in, that we can build applications on and make that highly scalable, very automated, and just kind of a no-brainer. So that's the basic idea. So Cassandra, think of it as managing deployments of a NoSQL database like Cassandra with a data gateway like Stargate on top of that within your Kubernetes provider of choice. Very simple. So there is a benefit here that's not immediately obvious in how this architecture is going to provide that scalability that you might want. So you might buy my premise that if you're familiar with Cassandra as a highly scalable NoSQL database. At the right of this diagram, you can see a Cassandra cluster. And what we do in Cassandra is manage that using stateful sets. So each Cassandra data center is modeled as a stateful set. And we can scale that cluster up and down through the requests that we make to the API server, right, to increase or decrease the number of nodes. So we can scale that cluster. We might want to add additional storage capacity. We also might want to add additional nodes to help keep up with the amount of traffic. Now, that's traditionally the two causes of people needing to scale up a Cassandra cluster is the amount of storage on the one hand, and the amount of compute that you need to service all the queries on the other. I don't know if I counted correctly. My fingers aren't working yet, but that's two reasons. So when we see that scaling going on, that's kind of been the historical struggle in Cassandra is how do I size my nodes properly so that I'm basically not wasting money when I size, if I'm scaling up for query traffic, I'm essentially scaling up the amount of compute I need. If I'm scaling up for storage, then I'm scaling up for the amount of storage that I need. So people are like, well, do I optimize the sizing of my nodes for compute or storage? This is an architectural option where you actually don't have to do that anymore. So when you have Stargate nodes that are configured with a Cassandra plugin, those Stargate nodes are actually aware of the topology of the underlying Cassandra cluster, and they basically act as proxies that can service queries. So now to scale queries, I can run Stargate on maybe some more compute intensive nodes, scale those up, add more nodes there, like you might see here. And now I'm scaling my queries separately from being able to scale my backend database. And of course, we run these Stargate nodes because they don't have any underlying storage requirements. They can just run in a replica set. Again, that makes them slightly easier to manage from that Kubernetes operator perspective. So I thought this was a pretty cool architecture. It turns out we didn't think of the idea of that last. So this is not a new idea. This is a talk from either further back in the Wayback Machine. This is another Cassandra Summit 2016 talk. And Eric Lubo gave a talk about this concept called coordinator nodes. And it turns out they were just running a layer of Cassandra nodes that were configured not to store any data. They were configured only as coordinators or proxy nodes that handled query traffic and then routed them to the other backends. So don't be fooled. There's really not that many new ideas in computer science. We just get better at doing them and maybe recycle a lot of those of those same ideas in a better form. So wanted to offer this as tribute to some of the great work that has gone on before. All right, so how do we get developers interested in doing this? I'm assuming that we got a lot of kind of the data crowd here, DBAs, SREs, but we probably have some developers here too. If you're not a developer, how do you get the team interested? My number one advice would be to get them to go to the stargate.io website and really just kind of try it out. It's pretty easy to do. You could try it out, download directly and install yourself. You can get it as part of the Cassandra distribution, which is pretty drop-in easy. The REST API, of course, it has a Swagger integration, of course, as you see here. It's a simple API. It basically operates on top of an existing CQL schema that you have already, or it actually allows you to create through the REST API new schema as well. So I'm just getting a few highlights here. I put a link to where you can find the getting started documents for Stargate. The second variant that we're seeing a lot of growing popularity and uptake with is the GraphQL API. So we've been talking a lot with Apollo GraphQL about the integration of this into various toolkits, like GraphQL Playground, making it accessible there. So this exposes an existing CQL schema as a graph SQL endpoint. And so this gives us more fine-grained control. I love GraphQL because it allows you to, instead of getting the whole entire payload of an object from a REST API, you can actually selectively pick the fields that you want to get out of that API. You could do awesome things like composing bits from different services. It's almost like a join layer for the NoSQL crowd. So this is a great option as well. That's generating a lot of interest. And then document API. This is kind of a groundbreaking thing for the Cassandra crowd because a lot of people really like the schemaless sort of data API that Mongo kind of provides with its document. So this is an equivalent way to do this in the Cassandra world, where you're basically just writing documents. And it doesn't matter what the fields are, it's going to get mapped correctly onto the underlying database without having a predefined schema. Very powerful. It's still quite fast. It uses basically kind of a document shredding approach where different pieces of the document are kind of written out and then assembled quickly together with queries that run in parallel on the back end. I'm going to do some hand wavy magic now because I totally don't have time to explain that in a way that will help you in this short amount of time. So go and check out the document API through the quick start guide as well. Now, we're working on a whole ecosystem of drivers and SDKs. This is actually where we could use a ton of help because, whether or not your exact combination, let's say a preferred language and API has an SDK for it available, may or may not be there yet. So, you can think about the combinatorial matrix that we need of API plus development language. Or of course, you can always just code to a REST API directly in your favorite application language, not saying that you can't do that, of course. So there are a lot of drivers that are available. There's going to be more SDKs coming online that hit these different Stargate APIs. And it's a great community to collaborate in. So I am going to end kind of my main body of my presentation here with this basic question kind of turned on its head, which is, instead of what is the data language of data on Kubernetes, what isn't the language of data on Kubernetes? We can get any API we want now, so let's do it. And that's basically the presentation. I'll drop a few links up here I hope that I've piqued your interest enough for you to go and check these things out on your own time. And then I'll take whatever questions I have. I have some compadres of mine here in the chat. So hopefully we can swarm on anything that we see here and get you our best answer. If not, the Stargate community has its own kind of chat and forum where you can go and ask those questions as well.
Good stuff, Jeff. Awesome. I think it very, very nice to come full circle with starting what is the language and what isn't. Your compadres are doing an awesome job here in the chat of responding to all the questions as they're coming in, getting some really, really good questions about data capture, about folks with different profiles, about whether or not Cassandra supports subscription, Firebase style. We got quite a few things coming in here. Let's see. For you, what has been, what has been one of the biggest challenges of being in this Stargate project?
I think it's kind of like looking at the volume of what are the different possibilities and the different APIs that people need, and just kind of figuring out where to concentrate first. So really being able to get that signal. A lot of the technical problems are pretty straightforward. I mentioned the idea that we found ourselves kind of writing that same boilerplate data access code again and again. So it's not that it's that difficult technically, it's just kind of the volume of work that you're kind of trying to consolidate and make it so people don't have to write again and again, if that makes sense.
Yep. Nope. Definitely very much so. But it sounds like I said, the responses that we're getting here are very, very positive. So I think What you need to do now, Jeff, is to go to bed. Yes, you got it. You got it.
Well, I'm one cup of coffee in, Bart. So,
okay. So
like,
we were actually commenting
it,
on that. We were commenting on that in the chat. I was like, okay, Jeff's got a really nice collection of swag coffee cups, but is he drinking one cup of coffee from each one of them, or how do you get this energy at 3:30 in the morning?
I took that photo when I joined DataStax. I'm pretty sure that I've broken at least one of those mugs in the following years, although I don't remember which one exactly. So.
Okay, so thinning out giving yourself more options for storage. We can think of it that way. That's good. All right, well, perfect. We are right on time for our next talk. So once again, Jeff, thank you very, very much. Looking excited to hear some from other folks today from DataStax later on. As Jeff mentioned, there's going to be some other things more about Kate Sandra that'll be more specific to that. But I think it was a fantastic presentation. So thank you very much, Jeff.